In her nearly 22 years with cows and fish, she's been focused on working with landowners, communities, and natural resource professionals to help them recognize the value of riparian areas and what they can do to maintain these areas as healthy and productive parts of our landscapes. Her work with community leaders, organizations, and agencies emphasizes sharing lessons learned in effective program design and delivery. She combines wetland ecology research with her farm upbringing to help bridge science, management, and education. And she believes strongly that those who manage and use the land are critical to ensuring a healthy landscape. So thanks for being here, Norine, and I'll pass it over to you. And if you would like any extra support during the session, I'll be paying attention so I can read out questions from chat and any of that.
Great, thanks so much, Sarah. Can you hear me okay?
Sounds good.
Awesome. So I will just bring up my presentation then. Of course, the Zoom thing is hiding my maximize button. So hold on a second. It's not wanting to let me access that spot on my screen.
Such a classic problem.
There we go. Let's try that. That should hopefully work.
Looks good.
Good. And I just want to actually, it looks like, are you guys seeing across the bottom the videos, or is there a gray space across the bottom?
It's just black at the bottom.
Okay, good. Perfect. So thank you for the opportunity to speak today. I really appreciate it. And thank you for those of you that have joined us today. I hope you get some really useful information out of this. And when Sarah and colleagues approached me to ask to do some workshop-y session on something, then it was like, okay, well, how do I do that on Zoom? And so I'm going to start with a presentation for some of the fundamentals, and then I want to spend some time kind of doing math, which is, you know, the workshop-y piece, like working together through questions and answers and sort of talking about how do you actually figure out these things called stocking rates and carrying capacity. But I guess I want to start off by saying the whole point of this is that you're trying to manage during drought, but you're also trying to manage generally effectively, right? We want our grazing resources to be healthy, and we want them to be productive and sustainable into the future. So if not the same, then even better than they are now, perhaps. So that's what I want to start off with, is some basic underpinnings of what that might look like. And so I'm going to try to use my button. It's not cooperating. I don't want to triple click and then it's like zooming forward. No, now it's not changing screens for me. Okay, there we go. So regardless of where you're participating from across Canada, our grazing resources are really important for livestock production. They might be very dry. They might be very moist, they might be grasslands, they might be forested, they might be next to water bodies. Of course, the work we do is often integrating managing near water, so riparian areas, and non-riparian areas. But really the grazing principles and practices I'm going to talk about are relevant no matter what kind of grazing resource you have and how you're grazing. It's just a matter of application is going to be a bit unique for different situations. So when I talk about riparian, I'm meaning that transition zone between water, the aquatic zone, and the upland or the terrestrial zone. And it is a transition. There's not exact line that this is a dotted line. It's that moist area along shorelines, stream banks, rivers. It's often part of our grazing resource in addition to the drier adjacent uplands, whether those are grassed or some other forages like alfalfa or mixtures or forested situations. And the reason we care about these places is not just as a beef or other kinds of livestock resource to feed animals. It's because they're important for other reasons. We want our pastures to be healthy because they contribute to water quality in the big scheme of things. They contribute to biodiversity. They contribute to carbon sequestration and storage. And in order for these pieces of the land, whether they're riparian or non-riparian, to function, to do those kinds of things like trapping runoff, storing carbon, rebuilding soils, providing habitat, they have to be healthy and functioning to do those things. And when they do, of course, then they become great resources. That primary productivity they create gives us something to feed our livestock. So how do you get those functions? How do you make them happen? Well, it all comes down to 4 basic principles. And these are, I would say, tried and true, long-standing understandings of range and grazing management, regardless of where you are or the kind of style of or pattern of grazing you apply, whether you're mob grazing, high intensity, rapid rotation, or giant extensive pastures. The same principles basically apply. It's just how do you make them work in your specific situation. So the first, of course, is balancing supply and demand. If you have too many animals for the available forage, you're not going to be in balance. It's going to be important to distribute livestock fairly evenly, but not necessarily exactly evenly. Like you might have purposefully uneven grazing, for instance. Avoiding and minimizing grazing or for those sensitive periods, but also sometimes those vary, and I'll talk more about when that is. And then, of course, providing rest, because plants, in order to grow again, have to have the resources to do that. And that rest allows them to do so. So I'm going to talk more about sort of the carrying capacity aspect of this in the sort of the math part, the stocking rate and carrying capacity calculations. But in order to balance our supply and our demand, that is why we need to understand carrying capacity. How do we know what our land can produce and therefore what we can harvest? And, you know, in this case, in the picture with beef or sheep or whatever other livestock you have, if you don't know what that baseline amount is. And it, of course, changes year to year. It changes based on geography, and it can change on the same site over time. So I'll talk some more about those things. Providing effective rest is, of course, giving chance to plants those chances to regrow, rebuild reserves, which is primarily in their roots if you're talking grass or forbs, broadleaf plants. Trees, it's a little bit different, obviously, or shrubs. But what we see above ground is replicated and related to what's below ground in terms of root reserves. So if we take off the top too many times, give it too many haircuts, then the healthiness of that plant is reduced below ground. It loses the ability to tap into nutrients and soil moisture as deep as it would otherwise. This is a classic example of a fescue plant where they, in a greenhouse, you know, grazed it with scissors multiple times on the far right, a whole bunch of times, repeatedly, very short, versus the far left, which was unused at all. And you can see the impact that has on the plant resource. If you don't have deep roots, then they're not tapping into the resources that are out there. And you're not obviously as drought proof, because if you don't have deep roots and you've only got shallow roots left, then when there is scarce moisture or scarce nutrients, but a particular moisture on the drought side, you're not going to be able to reach into them. And therefore your plants are going to be much more susceptible to that up and down moisture gradient when less production can be possible if they can't get water. The other important reason to understand carrying capacity, distribution, and balancing supply and demand is, you know, think of it as a financial example. Our soil and our plants are the capital which we rely upon. The piece that we graze off or harvest with our livestock is the interest. You got to keep the capital intact and healthy. And if you deplete the capital, as the picture on the right shows, you deplete the future opportunity for interest as well. So here's an example of a really simplistic sort of idea of rotational grazing. And really everything from mob grazing, tons of small paddocks, daily moves, to 2 pastures all season long, like switching between 2, is rotational grazing. They're just different scopes and scales of frequency and intensity. So, you know, using that to figure out how often and how long, of course, is related to how much they produce, you know, and each place will be different, of course. Here's an example from near the Cypress Hills. You can see the dark areas. This is an air photo, are sort of forested and shrublands. And then the tops of really, really big hills are basically open grasslands. And this was one giant pasture of 2,500 acres. About 20 years ago, and they, you know, recognized they had poor distribution, and they really needed to trying to make some changes. And one of the things that they did is they basically just cut it in half with this sort of dash line across the middle, created 2 pastures. They had the exact same size of overall area, the exact same number of cows, but what it led to is a better way of managing where the cows were spending their time. They put in some watering systems, which are the S's you see, the S you see, some elevated water, because these are very like intense terrain, so really big hills. And that allowed them to control timing of use in each piece. So they basically did a switch called a switchback rotation. So basically using one pasture for 2 months, split up, and the other. So it's, in this case, it's 4 months of grazing, June, July, August, September, 2 months in one, 2 months in the other. But the first one is June, then the next one is July, August, and then switch back to the first one, because the spring pressure is always harder on plants. And you can, I mean, what they did is they got a lot of improvement with health from those areas that had been being overgrazed. Some areas had been being undergrazed because this was such a huge area. They also saved on their cost of their bulls, because they actually had so much less area at 2,500 acres that they needed less bulls. So, you know, they save money there, and the pasture over the last 20 years has had improved quite a lot. So this is just an example of how, you know, these kinds of things can add value. This is an example that you can see. The picture on the left is kind of like a battery showing it's your energy reserve for your plants. If you have overgrazed a pasture like this picture shows, the plants don't have reserves. They don't have the ability to grow very much, because they all their carbon, all their carbohydrates have been lost, or a lot of them, and they're just constantly putting out their little solar panels to capture new energy, to put out a couple new blades. They don't have deep roots left. So they don't have a lot of reserves compared to if you have kept them healthy. This is the same stream about a half a mile away in the same owners, different kind of grazing management, more rest, more balance to what's actually possible here. And you can see that this site in a dry situation is going to have very little opportunity to grow at all. There's going to be little ability to respond compared to this site. This obviously hasn't been grazed in this photo, but then a site like this always looks like it's been heavily grazed, especially in dry years, because it just can't ever get ahead except in really wet years. It's always kind of like trying to play catch up. Whereas if you keep your battery, so to speak, charged, you have the ability to, again, take more of that reserve off, and the plants remain healthy and productive. The third principle, of course, is avoiding those sensitive periods. And I'm just going to see if I can, I'm having trouble seeing what I'm not sure if you guys are seeing the bottom of the screen. Are you guys seeing below this what says dormant, growing season, and dormant? Are you seeing content below that? Okay, good. I can't see it because all of your pictures are across it, and for some reason Zoom has locked the videos there. So as long as you can see it, that's good. So this is just a picture, basically, kind of a graphical representation of what happens to plants. And I'm sure many of you know this, but obviously in the dormant season during winter, or even in drought, in extreme drought, plants are dormant, right? They're not growing. And they're actually, you know, if you think of this is a timeline over the course of a year. So January through the summer, then back into the winter. This is the amount of energy a plant has on the left. So they start let's say they start in January, having lost some of their reserves from November and December. They're going down, downhill. They become in an energy deficit, and they're actually, you know, in a negative way. They're using up resources that are causing like loss of roots. And then they start to grow in the spring. And as they start to grow, they still have to draw down energy, because before they have green leaves, they can't photosynthesize. They're stealing more energy. Then they get to about maybe the 2 to 4 leaf stage, and their net gain is more than their net use. So they're gaining more energy, they're growing up. So their energy is going up. And that's in that period when they're in an energy deficit. Of course, that's why grazing hurts the plants, because they're drawing from their reserves and not just from new growth. And so if you cut them off or eat them in that period, they have to go deeper into deficit before they can grow up. So the goal is, of course, to try not to graze them or in those periods. Or if you do, to be really careful. And the thing is, your growing season in a drought can be really short, as you all know. Maybe it doesn't happen at all. In some areas, certainly last year, basically people never saw things green up at all because they were so dry and there was so little right combination of moisture and heat at the right times when there maybe was a little bit of available moisture. Plants are kind of stuck in that zone. So that's why then it's that much harder on the plants for the next year. The other sensitive time that you want to think about is, excuse me, is soft soils. So mostly that happens in the springtime, like when we have moister, softer soils, but it can happen in all locations like riparian areas, wetland margins that are wet on an ongoing basis as well. If you have a few weeks of moisture conditions on average, it can happen at any time of the year, really. And you end up with what we call pugging and hummocking. So these humps and these holes where the hooves that push down the soil and the adjacent soil gets pushed up. So this is really damaging to your resource because it's not as productive. You have compacted soils, obviously, and compacted soils don't grow as well if they don't store water, that sort of thing. So the last principle is distribution. So I said you might want it even, but you also might not always want it exactly even. Maybe you want patchiness for wildlife use. Maybe some areas are more sensitive than others, so you actually want patchiness. And one of the biggest ways to achieve this is, of course, fencing like with like. So when you have floodplains or stream sides and wetlands, and you have forests, and you have tame grass, and you have native grass, if you have all those things together, it's really hard to manage the grazing timing because those have very different needs. So fencing like with like is really helpful. You know, they don't have to be small paddocks, but they, you know, it does make sense to separate hilltops from bottomlands, forest from tame pasture, because they have very different grazing needs. And, you know, this is an example in this shot of a producer we worked with who, this is a wetland, a sedge, what you might call slough grass, but sedge dominated wetland with lots of willows and aspen around the edges. And he wanted to graze it, but to avoid the sensitive times, because it's a wetland, he grazed it when it's frozen. Only winter use to minimize that physical impact that would otherwise be present. And it doesn't really have any standing water. Generally, it's just one of those places with really abundant forage, as you can see. So here's an example of you know, maybe everybody's situation being a bit different. You can see there's a bit of green next to this stream, but it's not like a lush forest or anything like that compared to the grassland adjacent. So the difference might not be, you know, really obvious, but they did recognize that resource close to the stream was much more valuable because it's very much more productive. It produces a lot more because of the extra water. It's a pretty dry landscape on the whole. And so they actually put a fence along the top. So you can see where my mouse is, this kind of high sort of valley side next to the stream. They basically fenced out the valley bottom so they could graze it appropriate to the right sensitive times for each location. And so that's what this is, just an aerial view of what that might look like on their places, taking out those sensitive pieces that have different time needs. And if you are doing fencing, especially around water bodies, really thinking about giving them as much space as possible, especially streams, because they do naturally move, they meander and carve new paths. And likewise, even wetlands and lake shores, which tend to move, not that the water body moves, but the amount of water changes in a drought. It could be a mile away or a half a mile away on a big lake shore. And then, you know, when you get some wet years, it's back. So, you know, trying to account for that, thinking kind of long term. In the past, I think there's a real tendency to, you know, fence as narrow as possible, close to the water's edge as possible, but it doesn't give you very much flexibility. If the stream moves and carves away your fence, you got to rebuild it, or flood damage. And of course, in drought situations, you can't graze something that's only a couple meters narrow. If it's meant to be grazed during dry conditions and it's too narrow, you literally can't really manage it effectively either. So looking at season-long grazing generally isn't the greatest strategy, like using one pasture the whole time. It is possible. We've worked with people who've used this and are very great at it. And one of their keys is good distribution, right? So it is, any kind of management strategy is workable with the right kind of management. Any kind of management can work. You might want to use things like temporary fencing for those sacrifice areas, those really sensitive areas when you can't use other kind of management tools. So if you want to outsmart a cow, and I hope we're all smart enough to outsmart a cow. You want to alter distribution, control access to preferred things like water, control the timing, of course, during vulnerable periods, adding additional rest, and make sure the balance of use and demand are together. And so that's kind of where we're going to go to focus on a bit more next, is how do you do some of those things? So this is an example of a site that I want to talk about that's northeast of Calgary in Alberta. So it's in the grassland. This is a really old air photo, I realize. But what happened was they basically, the two counties that had this gravel pit land also were grazing. It was grazing rented land from the counties, and recognized that they we're seeing a decline. And so from about to 1997, they had been pretty heavily grazing most of what you see that looks like kind of the gray area that's not gravel. And it was not that healthy. And so they implemented some new fencing and in a number of parcels. And so basically broke it into pieces so they could have better distribution, better control. And by doing that, they also could, control timing of each place better when it was suited. And they did reduce the stocking rate considerably because it had been quite heavily grazed for long periods. And this is just an example of some of the forage capacity that had been coming off there. So you can see in 2005, one of the parcels that was sampled, the forage productivity was 617 pounds per acre. And by 2011, it was double that. Now, of course, you can say, well, that could be because there was just a series of wet years. That's true. That's why long-term forage sampling data is important. You can't just base it on a few years, but it is easy to see in the pictures, which I'll show you in a sec, how much this site was improving. And that was because they took off some of the pressure and let it start to recuperate. And so you think, well, then I'm losing forage use. But in reality, if you could take half of 600 versus half of 1400, which is better, right? Like if you have to take some, leave some, it's better to have a bigger pot to take some from in the first place. So I'll show you some of the pictures. So this is an example of how the different parcels, so parcel 2 was this one, the upland piece, and then there's a riparian pasture, how over time, of course, the productivity, each of these pastures, except for the control, which they didn't change anything in, kept getting better in these different parcels. So here's a shot of, it is a foothills fescue grassland. So a lot of bare soil, quite a few broadleaf or forbs, it's not very productive site. By a couple years more. This was already quite a few years in rest. 2005 is just the first photo I've showed you. It's starting to look better. It's starting to look a lot better. There's just a lot more there. And this is 2014, which I don't have forage productivity for you, but what I've circled there is the native plant, the fescue, rough fescue has actually been found on the site again. And so again, if you take half of this or 3/4 of this, whatever is acceptable grazing, this is a lot better in a drought because I start with more. And so the key here is to have healthy lands always, but sometimes they have gone downhill from past management, including drought. If you have a few years of drought, you end up overgrazing more, you graze them a little harder or a little earlier than you intended, then you have to allow for time to recuperate, right? To bring those pieces back. So some of those rough fescue plants are not only considered highly palatable, but they're also really productive. They're also really deep rooted, so they hang on well in dry conditions. Most producers, probably when you think about across Canada, have tame pasture as well. That was native grassland, but the same concepts apply. It's just that tame pasture tends to have been bred. The varieties are bred for repeat use, and they can tend to be used a little earlier and a little more intensively and sometimes a lot more, depending on what kind of part of the province or country you're in. So what are your key distribution tools? So I encourage you to tell me what are the key things. You can do this in the chat if you like, or if you want to turn on your camera, you can do that too. What are the key distribution tools you have? And I'll ask Sarah to read out the chat, because if I turn it on, then I can't see my own screen. Any guesses? What are the key things?
In the chat yet.
Feel free to turn on your audio and just blurt out what are the key things you have to help distribute your livestock. No guesses? Number 1 is water. Sorry, is there an answer?
Oh, we've got a couple coming in
Okay,
now.
good,
Supplements, minerals or salt, etc.
great,
Water placement, mineral placement, and fencing and water. Yeah. Temporary fencing.
perfect. Exactly. And all of those things, those are your key distribution tools. Obviously, physical barriers like fences clearly tell the cows where they're allowed, or other livestock where they're allowed to be and not. But your sort of other kinds of distribution are important too. I see my numbers are going up. Anything else in there that's new, Sarah?
Joe has also suggested any grass mixes preferred.
Yeah, different kinds of forage bases to actually direct them to different places. Yeah. Okay, so let's just go down a bit now. Whoops. So salt and or mineral and water are probably the most two useful tools without fencing. Like obviously, if you're going to fence cattle, clearly you can put them where you want them. Those are really obvious ones that most people, of course, right away know. One of the really common sort of longer ago misconception is that you have to put your salt or your mineral with your water. But behavior research shows that that's actually not true. They tend to take them separately, and also they don't need them together. In fact, it's perfectly fine to put them in separate places because you get a lot more value because they're two different distribution tools. So important to try and put them in different places. So how do you drive through? The other one, which is often not really thought about, especially relevant on slightly bigger pastures, is herding. So whether that's hand herding, pushing with you're on a horse or on a quad or with your cat, with your dog, is herding is actually a really important distribution tool as well. So not suitable maybe for some situations, but it can be, because again, you're trying to establish a pattern, get them to spend time in a different way than they had before. So whatever kind of technique you're using, whether you're scattering salt to get them to use the weedy patches, or you're supplemental feeding, which is what's in the top left, or temporary or permanent fencing, all of those things are really important ways to do it. And the key is to not put your distribution tools next to each other, because then you lose that value. So here's an example of putting your salt or your mineral right beside your water source. Obviously, it just increases intensity of use rather than distributes livestock. The other thing we don't really think about is sort of other sort of physical features. So crossing spots, like elevated crossings, shade or shelter, windbreaks are also can be really useful in terms of directing use or intensity of use. Of course, they use them as rubbing spots as well, and that's why they hang out at them in addition to shade and shelter sometimes. Even if it's winter, so not just during the grazing season, right? Thinking about that's why so many people feed by spreading their round bales or their chopped silage on the field nowadays, because it distributes the livestock's nutrients without having to go in there and haul it around. So whether it's winter or summer, I think it's a useful technique. Some interesting research shows that almost all of the heaviest manure is going to be next to 30 meters or 100 feet of shade, because they spend more time next to it, right? So this is a good example. Every cow that, or in this case they were yearlings, was trying to squeeze into that little bit of shade that they could find. The other reason to use things like watering systems without fencing is they can still be really effective, right? There's great research from Ag Canada from almost 20 years ago now, and other parts of North America that really show how cattle will use watering systems that you provide, offsite watering systems from the trough, basically 80% of the time, even without a fence. So water has a really strong pull, and it's not going to be that way 100% of the time. You might have some anomalies, but most research across North America comes at that about 80% perspective. So whatever kind of watering system you use, whether it's portable, whether it's temporary, whether it's permanent, whatever kind of water source you have, use it to your advantage as much as you can, because we know also, this is Ag Canada research from a number of years ago, but watering systems pay for themselves, because cleaner water means healthier animals, more efficient animals that make more pounds, which then make more money. So every class of livestock will be affected differently, but even just pumping out of the same water body does pay for itself. So it's not only good for the pasture, but it's good for your pocketbook, obviously. One of the most important things to think about too is not putting your distribution tools on top of what they're supposed to be moving things away from. These are two examples where an offsite watering system here on the bottom, you can see this trough is basically put right on top of the draw where the water is coming from. And this is the same situation. The stream is right here, and the trough, which is just a flow through system kind of from a spring up ahead, is they're right on top of each other, the water source, and in this case, the trough. And it really negates the value of a distribution tool. So, so just keeping in mind those kinds of things. So whatever you're doing, of course, we want it to be practical and economical. And in this case, in those sites, restorative, and it has to be sustainable, something you can manage as well as actually has the intended consequence. So sometimes we don't meet all of those objectives because, you know, drought happens, life happens, or, you know, maybe it's land you're also not that familiar with, it's newer, or you have, you know, you're switching up your management, you don't know, but you might end up there too often, too long, with too many, or at the wrong timing. And so you haven't met those 4 principles, so you end up with potential issues. So understanding your resource is really what carrying capacity and stocking rate's about. If you know what it can support, that just helps you manage it better, right? It's about how do you monitor and manage if you don't know what you have. Many people do this intuitively. You've been grazing and managing your livestock for decades. That doesn't mean that you might not want to tweak it, right? You know, when you're changing up your pastures, maybe you've got new resources in the mix that you didn't have before. The fence lines have changed. Maybe you've got a different kind of tame pasture than you had before, or you're just changing things up, and you want to. You can't just sort of use the same eyeball technique you wanted to use before. So the first thing is to understand in your pasture, do you have primary range, like their favorite places? Do you have secondary range, the stuff they go, yeah, we'll get there after we eat the best stuff first? Tertiary range, which they go to only once they've eaten number 1 and number 2 areas, and then non-use areas that are either inaccessible or really unpalatable. Maybe they're super steep terrain or bog they can't walk in, or there's nothing, you know, worth eating in them. So understanding what kind of range you've got, and some range like this in this picture, number 2 and number 3, the forage quality is quite good. It's not quite the same as the tame pasture in number 1, but they don't want to go there if it's all fenced together and it's all one unit, because like all of us, we want to be in our favorite spots first, and then we'll get around to, you know, the going around the corner into the places that are less palatable, you know, reaching into the back of the cupboard once the favorite stuff that's out front is gone. So, you know, mapping it out, whether you do it in art or you go on GIS, and, you know, there's great tools with Google Maps now, and other kinds of techniques to map out what you've got in terms of types and areas. And then figuring out what can your land produce? What's its carrying capacity? That's really what it is. Carrying capacity is how much can it produce without any harm to the land and the resource base itself, so the soil and the plants. It means you're going to graze it, presumably. It's a great grazing resource, but how can I continue to have that same long-term potential opportunity? And that's what the carrying capacity really is. If you use it over the carrying capacity, that means you're whittling away at the resource. If you use under or less than the carrying capacity, that means you're leaving extra behind, maybe for a future emergency use, like in the next drought, or maybe it's not in as healthy a condition as you'd like, and you're trying to bring it back. So you want to leave a little extra. So you want to use below that carrying capacity. And in general, you always want to use below the carrying capacity, because you never know when the next drought is coming, or when you can't get out there for some reason, and there's a little bit of extra use. So you don't always want to be on the, you know, the thin line. You want to be allowing some buffer in there. So I'll talk more about that. So you don't want the pressure so intense that, again, you're reducing the capacity of the land long term. So carrying capacity is really the land's ability. Grazing capacity is what you can take to graze. How much you're going to need? Well, that's based on how many livestock you have, for how long you want them to eat. And then you're going to figure the actual stocking rate. Like, so what can that relate to? So here's an example of riparian versus upland forage production. So this is in Alberta, of course, because that's where we do our work primarily. This graph on the left is riparian production. This graph on the right is upland, so the adjacent pastures in the exact same area. So they're like within 20 to 50 meters of each other. The sites were chosen kind of in pairs. And you can see that the bars on the left in the left graph basically are taller, bigger, more production in riparian areas compared to the graph on the left, because riparian areas are wetter, which means they produce more. So if I can emphasize anything, all of your land is really important, but riparian areas are often under recognized for how much percentage they contribute to your forage base. And they are also really important for all the other reasons like water quality and biodiversity, just like the rest of your land is important. But if you, again, if you start with large amounts and keep them large and are taking some off of that for your use, you start bigger, you have more, right? So I can only emphasize that really as a really important take-home message. So the herd size, well, number of livestock you have, obviously. Many of you might be familiar with this term already, but this is where we're getting into stocking rate and carrying capacity. So what's one animal unit? An animal unit equivalent is basically a 1,000-pound cow with or without a young calf. And how much she eats is going to be what's equivalent to whatever else. So recognizing that most cows are not 1,000 pounds, obviously, you just make it an equivalent. So you do a little math. If a 1,000-pound cow is the average, or I'll say it's the official animal unit, then a cow that's 1,500 pounds is 1.5 of those animal units. And I'll just show you a graph that shows a few other animals. So you could have a mature horse or bulls, adult bulls. You know, you have ewes. So each size and type or class of livestock obviously has different animal unit equivalents. So if you have sheep, each ewe is equivalent to 0.2 of the 1,000-pound cow. It takes 5 of them to equal a 1,000-pound cow. You know, and these are generalizations. Obviously, if you know your stock is particularly bigger or smaller, more efficient or less efficient, you can adjust. So if you have a 1,000-pound cow, or you've converted it, that cow needs a certain amount of food every month based on her weight. And this is based on, you know, research over many decades of course of work. And a standard assumption is that a standard cow is going to eat a standard amount of forage. And so that's 2.5 to 3% of their body weight. And this is dry mass. So 2.5 to 3% of their body weight is needed. And that then equates to what we call 1 animal unit month. So in a month, they're going to eat 2.5 to 3% of their body weight. So if you use 2.5, you get 345 kilograms of forage. And this is dry matter is going to be required. So that's how you have to figure out how big your animals are and how many you have, because that's the demand side. Then you're going to figure out what do you have, what's in your pastures. So you can do it based on forage demand per area. So how many animal units per acre or per hectare. By the way, I'm mostly working in acres today because a lot of, at least Western producers are not using metric. So that's what I'm using mostly today. And then there's something called the ecologically sustainable stocking rate, which is basically similar to carrying capacity. It's what's, you know, something that you're not going to go over that. If you go over that, you're going to degrade the land, whether that's the plants, the soils, or both over the long term. So in Alberta, and I'm using an Alberta example because I realize there are people across the province, you need to know what kind of soil and moisture you have. So there's great resources on this in Alberta because we have had the range management program for a long time on public land, and there are 50 and 60 years of data on some sites, which is pretty amazing to help us understand what the rangeland reference areas are across Alberta. So it helps us understand that. And so for those in Alberta and those even nearby or having communities similar to Alberta, I encourage you to look up these tools. And there is a great fact sheet called Methods for Calculating Carrying and Grazing Capacity on Public Rangelands. And the rangeland classification tools, which I'm going to talk about, are there as well. And if you are in plant communities similar to any of that are in Alberta, these are really great resources. So this is an example, and I did do a couple a bit of looking quickly for, I don't know which are the accepted practices for every province, and I clearly couldn't show them all. So I just want to show a couple examples from the Alberta guides that if you're in the foothills fescue, which is, let's say, west of Calgary and far west of Lethbridge, you're kind of on the edge of the foothills, you're still in grassland, just, this might be a typical plant community, a foothills fescue Perry's oatgrass that produces 1,920 pounds per acre of grass plus forbs, or which are broadleaf plants. So you have over 2,200 pounds per acre. And then that's not the litter. So always think, don't count litter in your forage production, because your litter is your blanket. You don't want to eat your blanket. You want to keep your blanket on the land to keep your soil protected and the plants healthy for the next year. And in an emergency like a drought, litter is edible. You don't want to use it on a regular basis, however, your carryover, that extra material you would leave behind. And these numbers, when you have a guide like this, already tell you here for the plant community you have, it tells you the suggested carrying capacity and stocking rate for that site, which is pretty amazing. So if you're in Alberta, these are a treasure trove of helpful information of different kinds of plant communities, the recommended stocking rate that's possible to be sustainable. If you're in a place where that is not available, or like this is an example I chose from the Central Parkland, so think Central Alberta, like Red Deer, more mixture of grassland, small forested areas. They don't really have the long-term data in some of it, and all those breakdowns that I just showed for this, if they aren't there, they've got suggested rates in this case for a smooth brome Kentucky bluegrass dandelion community. Because they don't have as many years of data, they just don't break it down in as fine a scale. And this tells you that they're recommending 0.35 of an animal month per acre. That means that 1,000-pound cow, whatever she needs and her calf, for a month can last a third of her, basically a third of her she can eat for in 1 acre. So, or she can get a third of a month or a third of a cow. So that helps you understand that a bit.
I'm going to interrupt with a question here from
Yeah.
Amber Canyon. Are these suggested rates under continuous grazing? And if not, how many paddocks with what rest periods?
Yeah, excellent. It's irrespective of how many rotations. This is what the land can produce, not how you take it. So it doesn't matter if you go in there twice and take half each time, or 10 times and take a tenth of it each time. Of course, a lot of these are, this is a tame plant community, but a lot of the other ones will be native plant communities. So the question I would say, I know the next question will be, well, then how can I go back and regraze, right? And it is true that sometimes you can get more. These are the opportunities that are considered safe levels with long-term use. So on a tame pasture where you would expect more regrowth, and also where you would expect probably to be regrazing it quite typically more than once during the growing season, it's still factored in to the rates. And it's true that you might get more on your area, but in that case, this probably isn't the community you have. So I'm obviously only showing a tiny bit of the information, but each of these types has a whole page. It talks about the soil, talks about the plant community as a whole that's there. So you would, if you have a lot more production that's sustainable than this, you probably aren't in this plant community, you're in some other plant community. Yeah, does that answer the question, Sarah?
I think so. She also said, so it would be less than what you could do with rotation. Is that correct?
No, this includes rotation. So okay. This is what the land produces, not how you take it, like I said. So you might go in there twice, you might go in there 3 times, you might go in there once. It is definitely not assumed to be continuous grazing, like season-long grazing, let's say, or only one single pass grazing. This is, I know what she's saying is there's, you should be able to get more with rotation, but the plants still can only grow so much each year. Like that's what this is about. This is how much can they grow that season, that growing season. Now you can, I won't get into it too much, but obviously you can increase your productivity by how you manage. And you might over the long term increase your ability and therefore your carrying capacity. So in sites that you are improving the soil, maybe improving the plant community, like actually improving the say the genetics, but the varieties you have, you might actually, on tame pasture, you could be improving carrying capacity. But we do know, this is a generalization across North America, that of course there's been a lot of degradation of soils on cropland, on tame land, and on native pasture lands on the whole. And so in general, we have been, across North America, degrading soils. So, which is why the regenerative agriculture movement is really important, as to how do you sustain what you have, but also regenerate it. So you can increase carrying capacity over the long term, not like, instantly, obviously, because it's about changing the resource.
Okay, thank you.
Yeah. So this is an example of a site that we did some forage sampling for, and the exact amounts aren't important, but what I wanted to point out is the variability. This is the other thing that's really important in grazing, is you have to recognize variability in drought years, and average years are very uncommon. There's always a big spectrum and range, whether it's a dry or a wet year or somewhere in between, cold, warm, right? So just that's the other thing that's important in carrying capacity, is managing for the average or the normal, so that you can account for the extremes. Maybe on some years you leave a little, you use less, but then you have more for the year that's dry. So how do you estimate these numbers? If you, how much should you use? Of course, how much should you leave behind? Take half, leave half is an old stockman saying. It doesn't apply everywhere. In some sensitive habitats, 25% is all you can take, because they're, native grasslands and really dry areas just are not that able to reproduce more production. On some areas of tame pasture, it might be the annual production you might be able to take 75%. It is highly dependent upon your location. So it's basically how much am I going to use of what's there, right? So you want to leave stuff behind, whether you're eating it or whether it's trampled in. Or the stuff you're not eating or the stuff you're trampling in, it's still, you want to leave some behind. Obviously, if you take everything, the soil cannot be built. You're not going to gain carbon. You're not going to improve the soil, and the plants will have a lot less shade and shelter from extreme wind, desiccation, that kind of thing. So you want to have that extra litter, that blanket I talked about, and a safe use factor. These are just generalizations. Native grasslands and forests, somewhere between 25 and 50% use of the total production, and tame pastures maybe as much as 70. Some people might say higher. If you can manage it well, that might work. But again, factoring in how healthy are you starting and where you're trying to take your pasture is important. So let's say you have a pasture that's really, really healthy versus one that's really had a lot of years of overuse, that maybe you've been above carrying capacity. You would change these utilizations depending where you're trying to take it. Are you trying to keep it stable? Are you trying to improve it? Are you trying to just stay the way it is? So here's a really great way, if you don't have access to data at home in your province or great information, you can go out and sample forage productivity, gather the total production in a quarter meter squared frame, and multiply it by, once you dry it, take it home and dry it in your oven carefully, don't start a fire, weigh it on your kitchen scale and multiply it by 35.7, assuming you measured it in grams, because that's what most kitchen scales are going to be, and you'll get pounds per acre. So that's gathering the current year's growth. That'll tell you how much forage was produced this year if you dry it and weigh it, and times by that. If you have a 1 by 1 meter square frame, which is just bigger, obviously, then you multiply it by 8.92, and you can get pounds per acre. So if you know how many hay bales you take off of a path, sometimes you graze it, sometimes you take hay, how many pounds per acre of hay you have, you can roughly translate that, right, to how many pounds per acre of grazing you have. Those are only approximations, of course, they're not perfect examples. You obviously can't do that right now, it's winter time, but in the summer, at the end of the summer, or multiple times in the summer, usually you want to gather total production, so end of growing season. So you might want to not do it in June, for instance. So here's some math. So let's just say you want to sustain grazing at the whatever the carrying capacity happens to be, and I know that I've got a 1,340 pounds per acre, and I'm going to take half because it's a native pasture. And I have 1,350 pound cows, and I need her to eat there for a month. I need to know what the monthly amount is. 670 pounds per acre is what I'm going to consider that my carrying capacity, and I'm going to have 1,215 pounds per animal unit per month, which means basically half of an animal unit month per acre. So feel free to jump on here if anybody's having questions on the math here. So if you had this means that you have 1 animal unit month, so 1,000 pound cow equivalent on 1 acre, really only half of that cow, right? That's how much food you have available in carrying capacity. So I can put out, that's how long I could put that cow out there for. I could either put half of a cow, which I can't actually do, or for half of the time, half of my month on 1 acre. So I've already mentioned these examples. The other thing I mentioned is you want to just determine, are you starting in a healthy or less than healthy state? So this is the same plant community nearby, but different productivity, right? So, this is using a frame. This is considered a 1/4 meter frame. You have, well, actually this is 0.2. Let's just say this is this frame, and you can see in the same size frame how much is being produced. So you have not only less grass, but you have less litter and less productivity. So if you're trying to maintain versus improve, you're going to want to use a lower level of stocking rate. Probably leave, like in the case on the left, it's been in the past quite heavily used, doesn't have a lot of litter, it's susceptible to dry conditions. This is a grassland, obviously. Litter has a huge impact on your ability to produce. This is a shot showing some work on public land where they looked at precipitation that was above average, which is on the left, versus below average. And in sites that are unhealthy, this is, I think this is again a grassland situation. With above average precipitation, you lost 43% of forage production compared to 54% in dry years. So in drought years, you get hit way worse on productivity by not having litter. So really important during drought to have built litter before, because obviously you can't build litter during a drought very easily because you usually are struggling to have enough forage, but that's why litter is so important. In dry conditions, that litter actually affects your actual forage production, not just the litter itself. So here's a couple examples, some math. People want to have their calculators out. Again, you maybe know these for your area, or you have an estimate, and you can determine these for your place. So let's say you had an estimate of 2.7 animal unit months. So again, that equivalent cow, that's 1,000 pounds on a hectare. Maybe you have hectares you're working in. You want to take 70% of it because it's tame pasture. But I'm a little bit concerned because I'm there in May. This is the first 2 weeks of May. I want to use it a little lighter because it's a little harder on it early in the spring. And for Alberta, May would be early grazing. So then I'm going to cut that. I'm going to reduce my use because I'm using it versus, here's an example of the pasture chunk I'm talking about is 2 miles from water. I shouldn't assume that it's primary pasture. It's a long ways to walk for water if they're 2 miles away. So I probably shouldn't assume that they're going to graze it in that area like I would anticipate. Meaning my sort of factor of management issues, it needs to be, and you don't have to use 20% or 60%. These are your choices. Obviously, it's a point is to try to be thinking about how the cows use the land and using like safe use factors to plan this is not obviously going to be the case in small paddocks. So grazing capacity is the product of your stocking rate in the area. So, you know, how much can I stock and how much do I have? So let's run through an example, and I'll pull this up, and I'd like people to feel free to jump in and suggest an alternative for their area or their situation. So if they want to turn on, I can't show you an Excel file, obviously in PowerPoint. So I have a calculator in front of me, like I'm sure some of you do on your phone. And if you want to try and do this, feel free to, in the chat, Sarah, you can comment for me, or if somebody wants to just propose a pretend or one of your actual situations, we can run through it and try and address that. Do you guys want to propose a pretend site you know of, one of the, like somebody from the organizing committee?
I don't know of any off the top of my head. Maybe somebody else does.
I can give it a go.
Sure, go ahead, Catherine.
So my parents have, let's say, one pasture that's 160 acres,
Okay.
and it's mostly native Manitoba grass.
Okay. So would this like be tall grass prairie or more like
tall grass?
Probably tall grass prairie. So pretty productive.
Yeah.
Okay.
Pretty productive.
And do they, for instance, do they hay it, or is there some equivalent amount that you like? Do you think like I'm just going to guess because I really don't know the site, but how tall would the grass get, or how many 1,000-pound bales of hay would they get off of it if they hayed it per acre?
So height wise, I'd say above the knee when there's enough moisture, kind of thing. So like pretty good feet. They do hay it. I'm not quite sure how much they get off, but usually, let's say they use square baling. Maybe yeah, I'm not quite sure.
That's okay. That's totally okay. So let's say it's fairly productive, and again, I mean, somebody on the chat can feel free to suggest a stocking rate that they know, but let's just say it's equivalent to sort of halfway between these two examples of native grass and tame grass I have. Let's just say, so 0.4, 0.4 and 1.25 divided by 2. So let's just say it's 0.825. So that would be 0.825, so not quite a whole cow per month on every acre is what that theoretically could graze. So if you have, how many cows would they have on, let's say, and how big is that pasture? First, how big is the pasture, would you say? Is it a quarter section?
Yeah, quarter section.
Okay, so let's say it's 160 acres then. So 160 times 0.825 is 132 animal units. So on that pasture, it will, if our guesstimate of productivity, of course, is accurate, then it supports 132 animal unit months. So that means one animal for 132 months, or however you want to cut that into individuals. And we have this part of the equation doesn't have how many cows you have. That's the next part of the equation. So if you have 132 animal units, I'm just going to jot that down because when I move my calculator, then I'll lose that. 132 animal unit months. That's kind of what your resource is. That's how much you have available, right? So then you have how many cows do you have and what's your demand? Like, what do you need to feed them? So how many cows would they have? And again, they may not only have this pasture, but let's just say give me a guesstimate of how many cows you think would be using that pasture over this.
They have a pretty small operation, so let's say 60 cattle.
60?
Yes.
Okay, and these would be cows with calves?
Yeah.
Okay, so let's say, are they 1,000-pound cows? Are they bigger than that?
They're
What
Hereford.
breed? They're Herefords. So let's say they're maybe 1,200.
Yeah, I think that would be.
Let's say
about right.
1,200-pound cows. They could be certainly bigger, but that's not one of the large breeds. So let's say 1,200-pound cows, and you have 60 of them. So in this equation, you would put number of head 60, weight 1,200, and so to get the animal unit equivalent, of course, a 1,200-pound cow is just 1.2 animal unit equivalents because you're thousanding it by or divide by 1,000. So you have 1,000. Sorry, I can't do math in front of my speaking. So let's say you have 60 cows, right? So in this, oops, sorry, my mouse is sleeping. 60 here, right? Instead of 100, and instead of 1.5, you have 1.2 because we said they're 1,200 pounds, so that's 1.2 equivalents. So you have an equivalent of 72 head that are 1,000 pounds. And then how long would they graze? Is 5 months of grazing kind of out there? So let's say May, June, July, August, September. Would that be grazing timing?
Yeah, well, they do rotational grazing, so they have a few pastures that they move cattle to. But yeah, I'd say we could say on this particular pasture, let's say 3 months.
Okay, so let's try that. So let's say it was 72 in here. The animal units we have is 72 animal unit equivalents times 3 months gives you 216 animal unit months. Sorry, I'm just jotting this down because I can't actually see it on the screen myself either. So that would tell you if you have 260 animal unit months, that's what you need to feed these cows. I need to have the equivalent of 216 animal unit months. So, and we said before that we had 132 animal unit months, right? So when we did this page, we got that the land was that pasture was going to produce 132 animal unit months. And on this one, we got that from a cow side, we have 216. So clearly they don't equal, but let's just go to here. So if we put, what do we have available? This is just putting the two parts of that calculation all in the same sheet in small letters, so you can't see it as well. But it's all the same stuff we just did. So available, we have 260, or we have, sorry, 132, right? We have 132 available versus required. My mouse keeps hiding on me. Versus required, we have 216. So if you go 216 or 132, depending on 132 minus, we're 84 animal unit months short. So that means you really couldn't graze those animals for 3 months. But maybe you could graze them for, without having done the math, you could graze them for 132 minus 84. I just need to do the math again. Let's say times 2 months. 72 times 2 months. 72 times 2 months would be getting close because you're at 144, right? For the same number of head, 144, 132, you're getting pretty close. Maybe shave off a couple of days and it might be balanced. And again, this is a math exercise. It doesn't mean in a dry year that might not work. If there's very little production in a drought, it's only the average that we're talking about, the normal. If on a wet year you have twice as much productivity and you had a really mild winter and a mild spring and there's just the perfect growing conditions, maybe you have double the production this year. Could happen. I mean, grasslands and forage resources are variable. So that's where you want to compare available versus required. And a lot of producers I find, and I'm sure some of you listening have note that you know what to do because you just eyeball it and you've been eyeballing it forever. Like you know what the right amount looks like, you know what the right amount left looks like, you know when to take them out by that eyeball. And that's totally acceptable. But sometimes it's good to do a check-in and say, like, where am I at? And certainly if you have new land or you're changing up your pasture or your plan, it's a great way to sort of say, do the numbers make any sense? you know, aside from my eyeballing and my experience, which is really valuable, sometimes you want to know, does that make sense?
I have a quick question too. So I grew up with we had goats for a number of years while I was a kid. And I'm wondering, so if I wanted to figure out the same thing with goats, then I just change the animal unit, right?
Equivalence. Yep, that's right. The
Equivalent.
and I didn't show that, but there are tables, and I was going to say to Sarah and Tiara, I'm happy to send out the files I have. As they're Excel files, so you can actually use them, that have a whole bunch of different classes of livestock. I think there's llamas in there as well, and you know, so I just didn't show them all, obviously, but yeah, you adjust the animal unit equivalents.
Yeah,
Basically, smaller animals eat less.
And I guess like a lot of the principles that like you've been kind of running through here are as applicable to all livestock then.
Yeah, but for instance, goats, you would really want to be more cognizant of woody plants, because of course, their preferred forage is going to be really different. And so what might be preferred or primary range for a cow versus a goat, you know, not that they're typically out in the same kind of pasture setups, maybe because you need different kinds of fencing as well, but their primary range might be very different, right? Because their target or they prefer more forbs and more woody plants compared to a cow. So yeah, and the principles are totally the same, but you know, what's going to be, you know, preferred or palatable, it's going to then influence how they use the pasture very differently.
Yeah, makes sense.
So other questions on that? I was going to show like the other options. Sometimes, you know, like let's say it's a pasture you've done this before, or maybe somebody says to you, or on lease land or public land, it's got an equivalent of 26 animal unit months on it. Sometimes you know what you can graze, but then you want to convert that into how many animals, right? So in this case, you want, rather than saying I'm trying to match my herd to my land, or rather like I already have a certain herd size, you sometimes know that a certain pasture can produce a certain amount, and you can say, well, then how long can I use that particular pasture for? And so that's kind of, it's just basically flipping the formulas a little bit to say, convert your animals. In this case, if I already knew I had 26 animal units, or in like the case that we did together, 216 animal units with Catherine's animal unit months with Catherine, then I could say, with a 1,200 pound cow, how long could I actually use that? So you would, this is kind of doing what we just sort of roughly did. You take so let's just say we had 216 was our first, when you said, let's try and use it for 3 months, 216 animal units months divided by, and they actually had 1,200 pound cows too, which is great. Was, sorry, I'm just trying to do the math in front of you guys. 24, 2.4, whoops. That doesn't seem right. I got 90, hold on. Shouldn't do math on Zoom calls. Yeah, I think that's right, actually. So, because this was 26 divided by 2.4, gave you 10.8. So it's just that because we had 216 divided by 2.4 in this case, you'd have 90. You could have 90 head for this period, for 2 months on that pasture of your parents, if, you know, assuming the productivity was this, obviously, which we don't actually know, but that's the assumption. So you can, if you know the capacity of the land, the kind of productivity you have, then you can just say, well, how long will it support? If I want them there only 1 month because I'm going to have them over here for however other long, that's a way to do it. Or I want them there all summer, then this is the way to do that.
Can we do one more calculation example? We have a question from Joe.
Sure.
On 65 acres.
Okay. So do you want to, so just to back up, we're starting with all the raw data, the acres house. Let's just go back up to here then, so we'll kind of watch it through. Okay, 60 acres?
65 acres.
65 acres, okay.
4.5 tons per acre of hay yield.
So 4.5 4 tons?
4.5 tons per
Tons,
acre.
okay. Okay, so I need to figure out that in pounds. Are these tons or tons?
Tons, Canadian.
So I always forget this. I always get them mixed up. Is that is a ton 1,000 pound or is a ton 1,000 pounds?
Tons 1,000 kilo.
Well, that's the kilos. Somebody knows
You're
this in
looking
the
for
chat.
pounds?
Yeah, because we have to
Okay.
do it because this is pounds per acre because it's
Hello?
equivalent, right? Yeah. Hey, jump on in.
Yeah, a ton is 2,200 pounds.
2,200, thank you. So 4.5 times 22. Thank you. That's just not a number I use often. So that's going to be, I'm just chiming that. So 9,900 pounds per acre. Okay. So that's our pounds per acre.
1,200 pound cows.
Okay, 1,200 pounds. So which is a 1.2 animal unit equivalent.
And grazing for 5 months.
5 months. Okay. Okay, so let's just try that. So if our acres are 65 right here, we're going to go 65 times the, oh yeah, sorry. We don't know how much your animal unit months are. We need to go back a step. We know how much production we have. Just a sec. We have, so we actually almost need to step back a few more steps because we have the production, but we don't know, we haven't converted that into how much can you take. So let's assume, because you're doing it for hay, let's assume that your pounds per acre is fully usable, like, because if you can take it off in hay, you could presumably take it off with a cow and you've left enough behind. So I'm just trying to backtrack because here, this is where you need to convert it to, this isn't pounds per acre, this is animal units per acre. Just a sec. I need to go back a couple steps. Where's that slide? Because we need to convert it basically to what's acceptable. Because this is what we know. We know the weight, we know the poundage, we don't know what's the actual sustainable stocking rate. Right, that's we know how much we're producing, but we don't know what the sustainable stocking rate in this situation is. So that's the challenge because we filled in, we know head animals, it's this piece here. We have all that, no problem. It's the piece in here. What's the carrying capacity that we don't really know. We know how much we're producing, right? So I don't know if that's Joe, if you have a sense of that, like converting that 2,000. That's our challenge right here. Is we don't have that information right now because
well, what I did, 65 acres.
Yep.
On that amount of hay will give you, say, the 9,900 pounds times 65.
Divided by 65. Or no, it was per acre. Right. I see what you did. Okay, so you just assumed that's a fair assumption. Sure. Okay.
So you have that amount of total pounds.
Yep.
And then you figure out the dry matter.
Right. Yeah. Let's assume.
And then you go what a cow of 1,200 pounds needs per dry matter.
Right. So yeah,
that's how I thought.
Yeah. So let's assume your hay's pretty dry, but it's not equivalent to dry matter.
No, that's right. About 12% moisture.
12%. Okay, so let's just say it's actually 12% less than. So 9,900 times 0.88. So 88% of that is actual weight. So you have 8,712 actual pounds of dry matter. Let's say if we took off 12% of it, that's our per acre weight of dry matter, let's assume. And I'm timesing it by 65 acres, which gives me 566,280 pounds in my 65 acres. Or the other way of looking at it is I have 872 acres per pound times. And then did you use 2.25 for your cattle? Like your
Yeah, say you have a 1,200 pound cow
1,200 pound cow. Yep.
times 0.025. That's the 2.5%.
Yeah. Yeah.
So they
That's
eat
right.
30 pounds of dry matter per cow per day.
Yeah, that's right.
So
And
then
if you have,
can you then do 566,000 divided by 30? Then you have
Yeah.
so many cow days.
that's a totally a reasonable way to do it. So that gives you, I got 18,876 cow days. That's which is the animal unit AUDs.
Right, and then you divide it by 5 months, 150 days.
Divided by 5 times 3, let's say, well, let's just go 5 months. So in each month you have 3,775 months, or animal unit months, right? Because I divided by 5. And then this is a single cow, right? AUM. So I have 3,775 animal unit months. Sorry, it's hard for me. I can't look at the screen, obviously, and write in my notebook and use my calculator. So we have 3,775 animal unit months. Does that seem like, based on 65 acres and 80, whatever we said, 8,700 pounds of dry matter, I have the equivalent of just under 3,800 animal unit months.
See, what I did then is you have the 566,000 divided by 30.
Divided by, yeah, okay.
That was the 18,000 animal days, or I'm not sure how you call them.
And were you dividing by 30 for the days in a month, or because of the pounds
No,
per day
no,
of use?
that's the 30 days of dry matter.
The 30 pounds of dry matter. Yeah.
Yeah.
Yeah. Right.
Yeah.
Which 18,000.
So about 18,000.
Yep.
And then for 5 months, it's 150 days.
Mm-hmm.
So then you do the 18,000 divided by 150 is 120 cows.
100. Yeah, I kept all the numbers, so I had 125. But yep.
Okay.
For sure. Yeah, 125 cows, or depending when what stage you're rounding.
Right. Yeah.
Right. So in that case, on your 65 acres, on your 1,200 pound cows, for 5 months, you have 125 days, or sorry, 125 cows, 125 equivalent cows. Yeah.
Yeah, cows per that you can graze for 5 months.
Right. On the 65 acres.
Right. Yeah. Okay. So, well,
it is. I thank you. That was good. It is tricky because there are so many different ways you can come into this with, depending which pieces of information you have. And I'm not going to say that I do it all. I don't do it all the time, obviously. So when you start with the known pieces that are the actual stocking rate, the carrying capacity of your land, it's a lot easier, but you don't often have that. And I think the example you provided, which I really appreciate, is a good example. Have you grazed that land? Just out of question. I know you've been paying it.
Yeah, no, we have had it for a long time.
Okay.
And we have irrigation.
Yeah.
So then, you kind of know what's coming off from that land.
Yes. So would you say, based on the calculation we just ran, that approximate number of cows is true based on your experience?
I have. I think is a lot, but
as in too many.
Well, see, before we had dairy cows, and they are, say, 1,500-1,600 pounds.
Sure.
So that is quite different than beef cows. Yeah, but so this animal unit, that includes the calf that's on them.
Yeah,
okay.
That's right. It does. Now, if you're using, I don't exactly know how dairy cows factor into there, but maybe you would almost, I assume they have a lot more energy requirements. And so you not only need to adjust for their weight, but maybe you also need to adjust like higher. So if they're 1,500 pounds, maybe they're equivalent to 16 or 17 because they're producing so much. But I don't know what that conversion is for dairy cows.
Yeah, that's right. Because we switched to beef animals, and they are completely different animals than dairy cows.
Yeah,
So
for sure.
that's okay. Well, good. Thanks.
Thank you
This
for
has
jumping
been
in.
so good. I hate to cut it off, but we got a
I
few
know.
minutes over, so
Yeah.
we probably should. Do you have anything else that you want to say just to wrap up?
I should show my funding support slides, which, you know, all of us require funding to be doing the things we do. So thank you to an Alberta Agriculture Canadian Agricultural Partnership grant. So I'm happy. Like I said, I'll send out, if you want, I can send it to the organizers, the spreadsheets, and people can play with them themselves, put in their own numbers and things like that. And if people find that helpful, I realize it's a bit hard to show that on screen. So I'm happy to do that. Thank you for the opportunity.
All right. Thank you so much, Norine. This was fantastic. I learned a lot myself, which was very neat. Yeah, and we can totally send out the Excel sheets. We can do that shortly after the event. Thank you for that.
You're welcome.